Yeah, so we'll start with exercise 3.3. So first question is that we have proved that sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4 is equal to minus 1 by 2. So let us consider the LHS of this equation, that is sine square pi by 6, sine cos square pi by 3 and tan square pi by 4. So if you are confused with the radians, you can convert that to uh, degree. So the simple way to do that is sine square of, instead of pi, write down 180 degrees, that is 180 divided by 6 plus cos square of 180 divided by 3 minus tan square of 180 divided by 4. So this would be equal to 6 1 times and 6 sorry 6 30 times, and 3 1 times and 3 60 times, and we have 4 1 time and 4 45 time. So what we have here is sine square of 30 degree plus cos square of 60 degree minus tan square of 45 degree. So this is nothing but sine 30 is 1 by 2 whole square minus plus cos 60 is again 1 by 2, this is also whole square, minus tan of 45 is 1 whole square. So this is nothing but 1 by 4 plus 1 by 4 minus 1. So this is nothing but 1 by 2 minus 1. This is nothing but minus 1 by 2. So therefore LHS is equal to RHS. Question number 2. We have proved that sine 2 sine square pi by 6 plus cosecant square 7 pi by 6 into cos square pi by 3 is equal to 3 by 2. So let us consider the LHS of this equation. We have 2 into sine square pi by 6. Pi by 6 is nothing but sine square 30 degree plus cosecant square of, we have pi by 6 is nothing but pi by 6 is 30 degrees, 7 into 30 degrees is 210 degrees into cos square of pi by 3. Pi by 3 is nothing but 60 degree. So we have 2 into sine square of sine 30 degree is nothing but 1 by 2. 1 by 2 whole square is 1 by 4. 2 into 1 by 4 is 1 by 2 plus cosecant of 210 degrees. 210 degrees is in third quadrant, somewhere around here, right? So we can write this as cosecant of 180 plus 30 degree, right? So since this is in the third quadrant, we'll get minus cosecant of 30 degree, right? So cosecant 30 degree is nothing but 1 by 1 by 2, that is 2. We'll have minus 2 as this value. So we have minus 2 into cos square of minus 2, we have whole square, right? And we have cos 60. Cos 60 is again 1 by 2. 1 by 2 whole square is 1 by 4. So we have 1 by 2 plus 1 by 2 plus we have minus 4, minus 2 square is 4 into 1 by 4. So this is nothing but 1 by 2 plus 1, that is nothing but 3 by 2. So therefore LHS is equal to RHS. So question number, that is cot square pi by 6 plus cosecant of 5 pi by 6 plus 3 tan square of pi by 6 is equal to 6. So let us consider the LHS. So we have cot square of 30 degree, right? So plus cosecant of 150 degree plus 3 tan square of 30 degree. So that would be equal to cot square. Cot 30 is nothing but root 3 whole square plus cosecant 150. So cosecant 150, so it can be written as cosecant of 180 minus 30. So this is in, obviously this is in second quadrant. In second quadrant cosecant is positive. So therefore this value would be cosecant of 30 degree, that is nothing but 2 plus 2 plus 3 into tan 30 is 1 by root 3 whole square. So this is equal to 3 plus 2 plus 3 into 1 by 3 is nothing but 1. So this is equal to 6. Therefore LHS is equal to RHS. So question number 4. We have 2 sine square 3 pi by 4 plus 2 cos square pi by 4 plus 2 secant square pi by 3 is equal to 10. Let us consider the LHS. So we have 2 into sine square 3 into 45. 3 into 45 is 135 degree plus 2 cos square 45 degree plus 2 secant square 60 degree. It is not necessary that we have to convert this radians to degree. So if we are getting confused with pi, you can convert to degree and then proceed with the simplification, or else directly you can write the values of each trigonometric functions, it doesn't matter. So we have 2 into, so what is value of sine 135? Sine 135 can be written as sine of 180 minus 45. So in second quadrant sine is positive, so we have sine 45, so that is equal to 1 by root 2. So we have 1 by root 2 whole square plus 2 into cos 45. Cos 45 is also root 1 by 2 whole square plus 2 into secant 60. Secant 60 is nothing but 1 by cos 60. So that is nothing but cos 60 is 1 by 2. 1 by 2 we have 2. So we have 2 square. So we have 1 by 2 into 2 is 1 plus, again we have 1 plus 2 square is 4, 4 into 2 is 8. So we have 10. Therefore LHS is equal to RHS. So we have question number 5. We have to find the value of first one, sine of 75 degree. So we can write this as combination of two known values. So we do not know the value of sine 75 degree, so but we know sine of 45 degree and sine of 30 degree. So by this combination of two angles we can find the value of with the unknown angle. So as we can write the 75 as sine of 45 plus 30. right? So this is in the form of sine of a plus b. So sine of a plus b is given as sine of a plus b is equal to sine a cos b plus cos a sine b. So we can write this as sine 45 into cos 30 plus cos 45 into sine 30. So this is nothing but 1 by root 2 into cos 30 is root 3 by 2 plus cos 45 is 1 by root 2 into sine 30 is 1 by 2. So this is nothing but we have root 3, let us take 1 by 2 as common. We have root 3 by root 2 plus 1 by root 2. So this is nothing but root 3 plus 1 divided by 2 root 2. We can factorize the denominator, that is multiply and divide by root 2. Multiplying and dividing by root 2, we have root 6 plus root 2 divided by 4. This would be the answer. Question number 2. So the value of tan 15 degree. So this again can be written as tan of 45 degree minus 30 degree. We know the value of tan 45 and we also know the value of tan 45. So by the identity tan of a minus b, we know that it is equal to tan a minus tan b whole divided by 1 plus tan a tan b. So substituting according to this formula, we have tan of 45 minus tan 30 whole divided by 1 plus tan 45 into tan 30. So this would be equal to tan 45 is 1 minus tan 30 is 1 by root 3 whole divided by 1 plus 1 by root 3. So let us take the LCM. In both numerator and the denominator, we'll have root 3 minus 1 divided by root 3 in the numerator. In the denominator, we'll have root 3 plus 1 all divided by root 3. Root 3 in the numerator and denominator gets cancelled. We'll have root 3 minus 1 divided by root 3 plus 1. So we have to factorize the irrational number in the denominator. So we have to multiply and divide by root 3 minus 1 divided by root 3 minus 1. If we have plus here, we have to multiply with the minus. So what we'll have is root 3 minus 1 the whole square in the numerator divided by 3 minus 1. So that is nothing but, so if we expand this, we'll have 3 plus 1 minus 2 root 3 whole divided by 2. So we'll have 3 plus 1 4, 4 divided by 2 is 2 minus 2 gets cancelled, we have root 3, 2 minus root 3. So we have question number 6. Cos of pi by 4 minus x into cos of pi by 4 minus y minus sine of pi by 4 minus x into sine of pi by 4 minus y. So is equal to sine of x plus y. So this is the question. So let us consider the LHS. So we have cos of a minus b. So cos of a minus b is given as, so I will just write the identities that we'll be using here. Cos of a minus b is given by cos a, cos b cos A cos B plus sine A sine B. Also we have sine of A minus B. We have sine of A minus B, that is given as sine A cos B minus cos A sine B. So using these two formulas, let us simplify this question. So LHS will be equal to, we have first, let's take these terms. Cos of A minus B will have cos A, that is cos of pi by 4, into cos B, that is cos x. So plus sine pi by 4 into sine x multiplied by, again we'll have cos pi by 4 into cos y plus sine pi by 4 into sine y. So we'll have minus, this is the minus, into sine of A minus B, sine A sine pi by 4 into cos x minus cos A, that is cos pi by 4 into sine x multiplied by sine pi by 4 into cos y minus cos pi by 4 into sine y. Right. So we have in all the terms, observe that we have cos of so we can further simplify this. Since we know the value of 45 degree, we can write as cos x by root 2 plus sin x by root 2 multiplied by cos y by cos y by root 2 plus sin y by root 2. So we have minus of cos x by root 2 minus sin x by root 2 multiplied by cos y by root 2 minus sin y by root 2. So we can take 1 by 2 as common. Since we have to multiply this, root 2 into root 2 will have 1 by 2. So if we take 1 by 2 as common, we'll have, and then we'll multiply this. So we have cos x cos y plus cos x sin y plus sin x cos y plus sin x sin y. So we'll have minus cos x cos y, minus into minus we'll have plus cos x sin y. So again we'll have minus sin x cos y, minus into minus plus sin x sin y. So cos x cos y and minus cos x cos y will be cancelled. Also sin x sin y I'm sorry, this is again minus into minus plus, again we'll have another minus, this would be minus. So plus sin x sin y and minus sin x sin y will be cancelled. So the remaining terms are 1 by 2 into 2 cos x sin y. So this one term and this one term will be added, and plus 2 sin x cos y. So this term, I'm sorry, this is also again positive because we have minus and minus plus. Okay, so let's take 2 common and this will be cancelled. What is remaining is cos x sin y and sin x cos y. This is in the form of sine of a plus b. Sine of a plus b is given as cos a sin b plus sin a cos b, right? So this can be written as sine of x plus y. Therefore LHS is equal to RHS. We have question number 7. Tan of pi by 4 plus x whole divided by tan of pi by 4 minus x. We have to prove this is equal to 1 plus tan x divided by 1 minus tan x the whole square. So let us consider the LHS. We have, this is in the form of tan of a plus b. Tan of a plus b is given by tan a plus tan b whole divided by 1 minus tan a tan b whole divided by, we have tan of a minus b, that is tan pi by 4 minus tan x whole divided by 1 plus tan pi by 4 into tan x. So this is equal to tan pi by 4 is nothing but 1. Tan pi by 4 is 1. So we can write this as 1 plus tan x divided by 1 minus tan x. So this is the numerator, divided by 1 minus tan x whole divided by 1 plus tan x. So this can be written as 1 plus, if we send this would be multiplied to this and this would be multiplied to this. So we have 1 plus tan x divided by 1 minus tan x the whole square. So we have question number 8, that is cos of pi plus x into cos of minus x whole divided by sine of pi minus x into cos of pi by 2 plus x is equal to cot square x. So let us consider the LHS. We have LHS is equal to, so cos of pi plus x, cos of pi plus x is nothing but this is in third quadrant. In third quadrant cos is negative. Alright, cos of minus x is equal to cos x, and sine of pi minus x, so this is in second quadrant, so sine is positive. Cos of pi by 2 plus x, so since we have 90 degree, this will be complemented, so this will be complemented to sine, right? So cos is negative in the second quadrant, right? So this would be negative. So we can write the LHS as LHS is equal to, we have minus cos x into cos x whole divided by sin x into minus sin x. So minus and minus will be cancelled. So we have cos square x divided by sin square x, that is equal to cot square x. So question number 9. So this is cos of 3 pi by 2 plus x into cos of 2 pi plus x into cot of 3 pi by 2 minus x plus cot of 2 pi plus x is equal to 1. So let us consider the LHS. So we have cos of 3 pi by 2. 3 pi by 2 is nothing but 270 plus x. So this is obviously in the fourth quadrant, right? So in the fourth quadrant, cos is positive. So since this is we have pi by 2 forms, cos will be converted to sine. So we have sine x into cos 2 pi plus x, right? So 2 pi is nothing but 360 degree, 360 plus x is nothing but this is in first quadrant. So in first quadrant cos is positive. So we'll have cos x multiplied by cot of 3 pi by 2 minus x. So this is 270 minus x. So this is obviously in second quadrant. In second quadrant, cot and tan is positive. Since we have pi by 2 form, cot will be converted to tan. So we have tan x plus, we have pi 2 pi plus x. 2 pi plus x is nothing but 360 plus x. So this is in first quadrant. In first quadrant all functions are positive, so there will be no conversion to cot to tan. So we'll have plus cot x, right? So this is nothing but sin x cos x into sin x by cos x plus sin x cos x. I've just written the tan in terms of sin by cos and cot in terms of cos by sine, and then multiplied with all the terms, right? So we'll have cos and cos will be cancelled. Yes, sine and sine will be cancelled. So we'll have sine square x plus cos square x. So this is equal to 1. Therefore LHS is equal to RHS, right? Question number 10. So this is given as sine of n plus 1 sine of n plus 1 x into sine of n plus 2x plus cos of n plus 1 x and cos of n plus 2 x. So this will be equal to cos x. So let us consider the LHS. So this is in form of sin A sin B plus cos A cos B. So this is nothing but cos of A minus B. So let us write this in terms of this. Here what is A? A is nothing but n plus 2 of x, and we'll have B is equal to n plus 1 of x. It doesn't matter, right? So we have LHS is equal to cos of n plus 2 of cos of n plus 2 of x minus n plus 1 of x. So this is equal to cos of nx plus 2x minus nx minus x. So this is equal to cos x. So we have question number 11. So cos of 3 pi by 4 plus x minus cos of 3 pi by 4 minus x. is equal to minus root 2 sine x. So we have LHS is equal to, this is in form of cos a plus b. Cos a plus b is nothing but cos a cos b minus sin a sin b. So this is, we can write this as cos of 135 into cos x minus sine 135 into sin x minus, again cos of a minus b. So this is nothing but cos 135 cos of 135 into cos x plus sine 135 into sin x. So this is nothing but cos of 135 is nothing but 180 minus 45. In second quadrant cos is negative, so we'll have minus 1 by root 2 into cos x. So sine of 135 is nothing but minus 1 by root 2 into sin x minus cos of 135 is minus 1 by root 2 cos x plus 1 by root 2 into sin x. Right, so this can be written as cos x by root 2 plus, minus sin x by root 2 plus cos x by root 2 minus sin x by root 2. So this term and this term will be cancelled. So we'll have minus 2 by root 2 sin x. 2 can be written as root 2 into root 2. 1 root 2 will be cancelled. What will be remaining is minus root 2 sine of x. Right. Have question number 12. So this is nothing but sine square 6x minus sine square 4x is equal to sine 2x into sine 10x. So let us consider the LHS. So we have so this can be written as 2 sine of 6x plus 4x whole divided by 2 into cos of 6x minus 4x whole divided by 2. So into 2 of I just skipped one step. So to make it more clear, I can write this as sine of 6x plus sine 4x multiplied by sine 6x minus sine 4x. So we know that sine of a plus b, sine a plus sine b is given as 2 sine a plus b whole divided by 2 and cos of a minus b whole divided by 2. Also we have sine of sine a minus sine b is given as 2 cos a plus b by 2 and sine of a minus b by 2. So here a is equal to 6x and b is equal to 4x. So if we substitute this, the LHS will be equal to 2 sine of 6x plus 4x whole divided by 2 and cos of 6x minus 4x whole divided by 2 into 2 cos 6x plus 4x divided by 2 and sine of 6x plus minus 4x whole divided by 2. So this will be equal to 2 sine of 10x 2 sine of 10x divided by 2, that is 2 sine of 5x into cos x into 2 of cos 5x into sine x. So we have 2 sine x and cos x if we consider these terms, right? And also if we consider these terms, right, we have sine 5 into 2 is 10x and sine 2x, right? So question number 13, cos square 2x minus cos square 6x is equal to sine 4x into sine 8x. So we have LHS is equal to, so we can simplify a square minus b square, that is a plus b into a minus b, that is cos 2x plus cos 6x multiplied by cos 2x minus cos 6x. So this can be written as, again we have now the formula, cos a plus cos b is equal to 2 cos of a plus b by 2 into cos of a minus b by 2. Also we know that cos a minus cos b is equal to 2 minus 2 sine a plus b by 2 into sine of a minus b by 2. Alright, so we have these two here. A is nothing but 2x, b is nothing but 6x. So LHS will be equal to 2 cos of 2 plus 6 is 8x divided by 2, that is 4x into cos 6, 2 minus 4 is 2 minus 6 is 4, that is minus 4, x by 2 is minus 2x. Cos of minus x is nothing but cos x, so we can neglect the negative sign, we can write cos 2x into, this term will be simplified as minus 2 sine of 4x into minus of sine, so we can write this as sine of minus 2x. So this is nothing but 2 cos 4x cos 2x into minus 2 sine 4x, sine of minus x is minus, so this will be equal to plus sine 2x. So this will be nothing but 2 into 2 is, so we can write this as 2 sine 4x cos 4x multiplied by 2 sine 2x cos 2x. So this is nothing but sine 8x into into sine 4x. Question number 14. So we have sine 2x plus 2 sine 4x plus sine 6x is equal to 2 sine of, so this is equal to 4 cos square sine 4x. So we have the LHS is equal to sine 2x plus sine 6x plus 2 sine 4x. So we'll consider these two first. Sine A plus sine B is nothing but 2 sine of A plus B by 2, that is 2 plus 6 is 8 divided by 2 is 4x into cos of 2x. So minus 2, we can neglect the minus here, plus 2 sine 4x. So we can take the 2 sine 4x as common, 2 sine 4x, so we'll have 1 plus cos 2x. So this is nothing but 2 sine 4x. We can write this as 2, so cos 2x can be written as 2 cos square x minus 1, so plus 1. So this is nothing but minus 1 and plus 1 will be cancelled. So what we have is 2 into 2 is 4 cos square x into sine 4x, right? Next question we have question number 15, that is cot 4x multiplied by sine 5x plus sine 3x. Is equal to cot x multiplied by sine 5x minus sine 3x. So this is equal to, let us consider the LHS is equal to cot 4x into sine A plus sine B is nothing but 2 sine A plus B by 2, that is 4x, into cos A minus B by 2, that is x. That is equal to, cot can be written as cos 4x by sine 4x, so multiplied by 2 sine 4x into cos x. Sine 4x and sine 4x gets cancelled, so what is remaining here is 2 cos 4x into cos x. So okay, so we got something here. Let us consider now the RHS. So the RHS is nothing but cot of cot x into sine 5x minus sine 3x. So this is nothing but cot can be written as cos x by sine x multiplied by sine of sine A minus sine B is nothing but 2 cos of A plus B by 2, that is cos 4x into sine x, right? So this will be equal to sine x and sine x is cancelled, so we have 2 cos 4x into cos x. So this term and this term is equal, so therefore LHS is equal to RHS. We have question number 16. We have cos 9x minus cos 5x whole divided by sine 17x minus sine 3x is equal to sine 2x divided by cos 10x, right? So let us consider the LHS. We have So this is in the form of cos A minus cos B. Cos A minus cos B is nothing but minus 2 sine of A plus B by 2, that is 9 plus 5 is 14 by 2 is 7x into sine of A minus B by 2. 9 minus 5 is 4. 4 divided by 2 is 2x whole divided by sine A minus sine B. So we have 2 cos of A plus B by 2, that is 17 plus 3 is 20. 20 by 2 is 10x multiplied by sine of A minus B by 2. So that is nothing but 17 minus 3 is 14. 14 divided by 2 is 7x. So sine 7x and sine 7x gets cancelled. So 2 and 2 is also cancelled. The remaining terms are minus sine 2x divided by cos 10x. So we have question number 17. So sine 5x plus sine 3x whole divided by cos 5x plus cos 3x is equal to tan 4x. So let us consider the LHS. We have again sine A plus sine B is nothing but 2 sine A plus B by 2 is 5 plus 3 8 divided by 2 is 4x into cos of A minus B 5 minus 3 is 2 divided by 2 is 1 cos x whole divided by cos A plus cos B. So that is 2 cos A plus B is cos 4x into cos B is cos x. This is nothing but cos x and cos x is cancelled. 2 and 2 is also cancelled. The remaining term is tan 4x. So question number 18. Sin x minus sin y whole divided by cos x plus cos y is equal to tan of x minus y divided by 2. So consider the LHS. We have sine of A minus B, so that is nothing but 2 cos of A plus B by 2, that is x plus y by 2 into sine of x minus y by 2 whole divided by cos x plus cos y is nothing but 2 cos x plus y by 2 into cos of x minus y by 2. Again these two terms is cancelled. 2 and 2 is also cancelled. The remaining is sine by cos is tan of x plus y, x minus y divided by 2. So question number 19. We have sin x plus sin 3x whole divided by cos x plus cos 3x is equal to tan 2x. Again consider the LHS, and sin A plus sin B is nothing but 2 sin A plus B by 2 is nothing but sin 2x into cos of A minus B by 2, that is minus 2x divided by 2, that is minus x. Cos of minus x is nothing but cos x divided by cos x plus cos b. Cos A plus cos B is nothing but 2 cos A plus B by 2 is nothing but tan cos 2x into x minus 3x is minus 2x divided by 2 is minus x. Cos of minus x is nothing but cos x. Cos x is cancelled. So again what the remaining term is tan 2x. So we have question number 20, that is sin x minus sin 3x whole divided by sin square x minus cos square x is equal to 2 sine x. So we have the left hand side is equal to sine a minus sine b, so that is equal to 2 cos of a plus b by 2, that is 4x, x plus 3x is 4x, 4x divided by 2 is 2x, into sine of a minus b by 2, x minus 3x is minus 2x, minus 2x divided by 2 is minus x, whole divided by sine square x minus cos square x. So I'll convert the sine as sine to cos. I'll have 1 minus cos square x minus cos square x. So this is nothing but 2 minus 2 cos 2x into sine x, because sine of minus x is minus sine x, whole divided by, I'll also take minus common in the denominator. I'll have 2 cos square x minus 1. So this is nothing but minus and minus will be cancelled. 2 cos 2x and sine x divided by cos 2x. Cos 2x will be cancelled. The remaining terms are 2 sine x. So question number 21. So we have cos 4x plus cos 3x plus cos 2x whole divided by sine 4x plus sine 3x plus sine 2x is equal to cot 3x. So we have LHS is equal to, so I'll take I will group these two terms. Why? Because if we take the average, let's see, 4x plus 2x divided by 2 will have 4 plus 2 is 6, 6 divided by 2 is 3x, right? So if I consider these two, let's say for example, so 4x plus 3x divided by 2 is nothing but 7 by 2x. So this will complicate my problem, so I'll not take this. Instead I will group the first and last terms, right? So just write it once again. Cos 4x plus cos 2x plus cos 3x divided by, same in the denominator, sine 4x plus sine 2x plus sine 3x. So now I'll apply the formula. So cos a plus cos b is nothing but 2 cos a plus b by 2, that is cos 3x into cos x plus cos 3x whole divided by sin a sin b is nothing but 2 sine of a plus b by 2 sin 3x into cos x plus sin 3x, right? So now in the numerator as well as in the denominator, I'll take cos 3x common in the numerator, cos 3x. So the remaining terms are 2 cos x plus 1 whole divided by, I'll take sin 3x as common, sin 3x into 2 cos x plus 1. So these whole term will be cancelled. The remaining terms are cot 3x. Question number 22. So we have cot x multiplied by cot 2x minus cot 2x into cot 3x minus cot 3x into cot x is equal to 1. So I'll have LHS is equal to cot x minus cot 2x. I've written the first term as it is. So here I'll take the cot 3x as common. So I'll have minus cot 3x as common. So the remaining terms are cot 2x plus cot x, right? So this is nothing but cot x into cot 2x. So I'll write cot 3x as cot 2x plus something like this, cot of 2x plus x, right? So this will be equal to minus as it is 1 minus cot, sorry, so I have cot 2x into cot x minus 1 whole divided by cot 2x plus cot x multiplied by cot 2x plus cot x. So this term will be cancelled. So the remaining terms are cot x into cot 2x minus cot 2x into cot x minus into minus plus 1. These terms is again cancelled. Remaining term is 1. 23. I have tan of 4x is given by 4 tan x into 1 minus tan square x whole divided by 1 minus 6 tan square x plus tan to the power 4x, right? So I'll consider the LHS. LHS is equal to, I'll write tan 4x as tan of 2 into x, that is 2 into 2x. So tan 2x is nothing but, tan 2x is given by half angle formula, that is 2 tan x divided by 1 minus tan square x, right? So using this formula I can simplify this as 2 tan of 2x divided by 1 minus tan square 2x, right? Again I'll apply the tan 2x formula, that is 2 into 2 tan x divided by 1 minus tan square x whole divided by 1 minus, again tan 2 theta formula, we'll have 2 tan x divided by 1 minus tan square x. So we have whole square here, whole square. So this is nothing but 4 tan x divided by 1 minus tan square x whole divided by, I'll have 1 minus tan square x whole square minus 4 tan square x whole divided by 1 minus tan square of x, right? So whole square here. So this whole term will be cancelled with this square. So the remaining terms are 4 tan x multiplied by 1 minus tan square x whole divided by 1 plus, so I'll expand this, 1 plus tan to the power 4x minus 2 tan square x minus 4 tan square x. So this is given as 4 tan x multiplied by 1 minus tan square x whole divided by 1 plus tan to the power 4x minus 6 tan square x. That's right. Question number 24. Cos 4x is equal to 1 minus 8 sine square x cos square x. So consider the LHS. We have again cos of 2 into 2x. Cos 2x is given by 2 cos square x minus 1, right? So we have 2 into cos 2x whole square minus 1, right? So we can expand the cos 2x again. So we have 2 multiplied by 2 cos square x minus 1 whole square minus 1, right? So let us expand this. 2 into 2 2's are 4, 2 square is 4 cos to the power 4x plus 1 minus 4 cos square x minus 1. Plus 1 minus 1 is cancelled. The remaining terms are, I'll multiply 2 as well. 2 into 4 is 8 cos to the power 4x plus cos to the power 4x minus I'm sorry, I just made a mistake here. So this is only multiplied to this minus 1. So this 1 is not cancelled, right? Plus 2 minus 8 cos square x minus 1, right? So we have 8 cos square x. I've taken this as common into cos square x minus 1, right? So this is nothing but, I'll have plus 1 as well. So this is nothing but minus 8 cos square the sine square x plus 1. This is the answer. So question number 25. Cos 6x is equal to 32 cos to the power 6x minus 48 cos to the power 4x plus 18 plus 18 cos square x minus 1. So I'll have the LHS as cos of 2 into 3x. So this is nothing but 2 cos 3x whole square minus 1. So this is nothing but 2 into cos 3x is given by 4 cos cube x minus 3 cos x whole square minus 1. So by expanding this, I'll have 2 multiplied by 4 square is 16 cos cube whole square is cos to the power 6x plus 3 square is 9 cos square x minus 2 into 4 is 8, 8 into 3 is 24 cos to the power of 4x minus 1. So I'll multiply 2 as well. 2 into 16 is 32 cos to the power 6x. So I'll have 2 into minus 24 is minus 48 cos to the power 4x plus 9 into 2 is 18 cos square x minus 1.